and welcome to our Introduction to Softree Optimal webinar. My name is Erin Wozni. I'm going to be your host for this presentation, and I'm also the Business Development Manager over here at Softree. With me today is David Mills, one of our software engineers, as well as the PN here at our company. Now, before we get started, just a couple quick housekeeping notes. First of all, you are all muted. That is intentional. It allows the presentation to go a little bit smoother, but we definitely encourage you to ask questions throughout it. You can use your GoToWebinar panel. There's a question little box in there. You can type them in, and we will stop a couple spots throughout the presentation, check for questions, and answer them. And secondly, we are also recording this presentation like we do all of our webinars. The purpose of that, we get lots of folks who like to sign up. They know they can't attend the webinar, but it's the topic they want to see, so they can get the email with the video afterwards. So for the future, feel free to sign up for any webinar, regardless of whether you can attend it or not, and you'll receive the video. You're also able to share it that way. Now, today, we're going to be taking a deep, not too deep of a look, but a look at our Softree Optimal software. So whether you're a current Optimal user or just checking out what the heck it is, this webinar is going to give you a pretty solid introduction to what the software is capable of doing. And if we just advance the slide here, vertical alignment optimization really is the mathematical process or optimization process of minimizing earthwork and haulage costs given the constraints and costs that a user has defined, and it's capable of outputting the lowest cost vertical alignment. So what does this look like in a little bit more terms? So you're going to add in your existing ground and surfaces. You're going to bring in a horizontal alignment, some details about what your cross sections look like, as well as any constraints and costs that you have. And then what Softree Optimal does is it will give you the lowest cost vertical alignment possible every single time. And it does this often in a matter of minutes. Now, Optimal exists as a standalone program capable of being compatible with other CAD software, including Civil 3D and various Bentley products. We also actually have a direct interface that is nearly out of beta for Civil 3D, where you can actually manage a lot of your export functionality directly in Civil 3D and then bringing it into Optimal. And then for the road end users, which is our civil design platform, Softree Optimal actually exists as an add-on within the road end environment, so you're not needing to go anywhere else. So over the next 25 minutes or so, Dave is going to demonstrate some of the core functionality of Optimal, which really is all about optimizing an existing vertical alignment to minimize its earthwork costs. In doing so, he's also going to manage pits and track our material movement so you can save construction costs there, as well as comparing alignment options based on different costing data. Now, he's also going to demonstrate how Optimal is really not a black box. You're not just putting in magical numbers and it pops out something. It's really a powerful engineering tool that you can use to manipulate different design parameters, understand the cost implications from those changes, as well as allowing you to compare multiple horizontal alignment options. So Optimal is a very dynamic and powerful tool that can allow you to achieve some very interesting benefits, including saving your engineering time. As I mentioned, we're talking about seeing a vertical alignment generated in a matter of minutes versus considerably longer if you're going to be hand engineering that. The ability to quickly compare design variables, minimize your earthwork costs. Most of our clients using Optimal actually see a 10 to 25% reduction in their earthwork costs. In terms of design time costing, you're going to be able to see costing changes in real time as you design, and you'll see that today with Dave. And then as I mentioned this one before, but it is compatible with RoadEng, with Civil 3D, as well as with Bentley and 12D products. So that's just a quick introduction to some of the stuff we're going to be seeing today. And before I pass it to Dave, I am just going to share what else is coming up on our webinar calendar. So you've got some importing, exporting coordinate data and RoadEng coming up in a couple weeks. Quick and easy low volume road design with RoadEng end of September. advanced look at cross-section components. This is not an intro to. This is really getting into the nitty-gritty of our road edge program in terms of templates and cross-sections, and then resource road design and how to improve your workflows with LiDAR. So with that, I am going to pass it over to Dave.
Thanks, Erin. I hope my mic is working properly. I'm going to show the whole process right from the beginning. Let's just, can you just confirm that you can see my big orange flower, Erin? Good. Okay, well, let's get started. So I'm using our version 7 release. This is the current version that everybody who is up to date with our software will be using. I'm just going to start by creating a new location design. This is nothing that requires Softree Optimal yet. And this is a piece of LiDAR. There is a terrain feature in there. I'll just show you the plan view in a second. But basically, I'm tracking the center line, a surveyed center line, and using that as my initial alignment. So here's what it looks like. And yeah, a big chunk of LiDAR. This road exists. You can kind of tell if you look at the cross section that there's a little flat spot there. Where's the side hill? Here's one. Yeah, you can see that this is an existing road. You can tell by looking at the black line that represents the original ground. And first thing I'm going to do is just generate an alignment along this horizontal alignment. I don't have a vertical yet. The vertical is just showing the ground. Kind of interesting to look at the shape of the ground that you get from this LiDAR survey. We're actually tracking along an existing alignment, so you would expect that to be smooth and continuous. But what you're actually seeing here is, what does it look like there? About a decimeter plus or minus error in the LiDAR data. I don't think that's going to affect our volumes too much, but it's just kind of interesting to see that. Okay, so we've got the vertical ground of the center line of the old road. No point in realigning it unless we decide what the cross-section is going to look like. So I'm just going to go into our cross-section editor, bring in a suitable cross-section. We're going to use this one. And I just created this today. I've been wanting to make a new resource road template, so there's a small possibility it's not going to work perfectly, but it seems to work pretty well. Let's give it a good test. Okay, so this template has 2 layers above subgrade. I've set the running surface to be 5 meters wide, and that means that the subgrade itself is a little more because the capping layers here are quite thick. Okay, the part that the optimizer is going to be looking at is the subgrade. That's the red fill and the red cut. So it's going to be looking at those volumes. It's not looking at the layers above subgrade. That is going to be available in our next release, allowing the optimizer to include the costs of the surfacing above. It doesn't make much difference to the alignment because those numbers don't change very much when you move vertically. However, it does make a difference to your costing, and we want to make our costing as useful as possible. Right, so that's my cross-section. Unfortunately, I have to assign it, so let's do that quickly. It's using the default by default. That kind of makes sense. Let's put in the resource template. Good. Okay, I got my cross-section set up. What about ground types and costs? Well, for this example, I'm just going to use the default ground type everywhere. So yes, you can define different materials in the ground. You can define expansion, compaction factors, and so on. I'm going to ignore that for now. In terms of costing, however, that's also in that same ground types table. I am using cut of $12 per cubic meter and fill of $4 per cubic meter. that will be used by the optimizer to define how much things cost, earthwork-wise. In addition, there's information about hauling material. How much does it cost to haul it? Free haul, overhaul, and end haul. And these are dollars per cubic meter per kilometer. That's haul cost. And there's also a loading cost in there too. These are just my default values. They can be tweaked and fiddled if you need to make some changes, but for now we'll just work with the default. Okay, so it's very easy to get to the point where I'm at, where I have a horizontal alignment based on a survey. In this case, there was a road, so I didn't have to design the horizontal. That's a whole other can of worms, ball of wax. Let's just go with the easy route now. The horizontal is already made. Now we want to do a vertical alignment. So here's where I'm going to introduce the Softree Optimal panel, also called the alignment panel, because it allows you to create multiple alignments. The first alignment I have here is completely undefined, so I don't really need to keep it. But often you have a vertical alignment that you want to keep, so you start by making a new vertical alignment. So I'm going to make a new vertical alignment. I'm going to call it Quick Curves. And the first thing I want to do is set up the, well, that's the default, the Quick Curves. We'll see more about this in a little while. Let's go right on to the parameters that I think everybody's familiar with: maximum grade, minimum grade, K values. We're going to work with curves here. You can, if you want, design roads with a simple polyline, straight segments between points. And in that case, you don't set the K factor, you set the grade break in %. But we're going to work with curves. So I'm going to set my K factor to the default here, which is 10, and control points. This is an existing road, so I assume that the beginning is joining onto something. So I'm going to set the start of the alignment to have a fixed elevation. In addition, this is starting it's branching off a road that's already sloping. So I'm going to allow my grade to be 5% plus or minus 1 here. No, 4 plus or minus 1. There we go. And at the end of the road, let's put in another control point. We'll pick up the elevation from the ground here and assume again that it must end where the existing road ends, and that the grade can't change too much. In this case, I'm going to allow it to change from 0 to plus or minus 4. All right, that's all I need to do to start this alignment. There's a lot of other things I can do. I can add borrow and waste pits. Of course, I can modify the costs. And there's a few constraints in here that I could be working with if I wanted to. Let's go with a fairly simple calculation and see what happens. So one more thing before I actually start. Even though this alignment doesn't exist, I can still cost it. And what's kind of interesting here is that the software can run an experiment where it tests to see how many samples you need to get a relatively accurate cost. It doesn't always work well with the ground. It's really designed to work with an existing alignment. Anyway, it says if you sample this alignment at 5-meter intervals, you will get a very accurate cost, better than 1% from the true cost, which would be the cost if you had sampled, oh, I don't know, basically continuously. Okay, I've done this with an alignment in here, and I found that I got a slightly different number, and I'm going to use that slightly different number. So I'm going to sample at 10-meter intervals. Now, if I take all points, I've got lots of them. The optimizer can work with 500 points, but it would be a lot faster if I only use those 10-meter samples. So now there's only 200 points. So let's run the optimizer, and I'll kind of, while it's running, explain why it takes longer. Okay, I want to create a profile and let it go. This process, we call this preprocessing, is where it samples those 10-meter intervals along the alignment in the station dimension. In addition, it tries different vertical offsets from the existing alignment. The existing alignment is the ground, so it's just going up and down from the ground, and it's trying different cross sections. And it's calculating all those in advance so that the optimizer doesn't have to do this recalculation during the optimization process. So that takes a pretty well-defined length of time. It's just counting down, and then it does a quick, there, finished. Okay, now we're working on the actual optimization. Oh, finished already. And I called this optimization quick curves because it turns out that once you finish that pre-process, quick curves does tend to optimize very quickly. Right, so I sampled at 10-meter intervals, and I've got a balanced alignment. No excess fill, no excess cut required or material required. No overflow, no underflow. But when I did a recost afterwards, I used all the possible cross sections, and it comes up with a small overflow value, underflow, sorry, so it's short a little bit. That's pretty typical. There's my result, that blue line there. So let's set that current and see what it looks like. Notice that the mass hall diagram and the cross sections and everything are still referring to the original ground. That's not very interesting. So now I'm going to set this as the current alignment. So we've got multiple alignments now. There we go. And the first thing you'll notice is that, wow, there's a lot of curves in there. There's curves basically every 10 meters. So this is not something that would be easy to go out and design, to specify. It's got hundreds of curves. Let's turn off the display of those for a minute. But it's an alignment, and it's got a mass hall that is pretty close to balanced, particularly at the end here. At the beginning, we got a problem because it can't start at a grade greater than 5%. So, you know what? I think I forgot my tolerance. Let's run it again. The starting grade there, if we just look at the very first curve, I don't want to go through the whole bunch of them. That point there, the starting grade is showing in my curve panel here as being 4%. So let's just go back to the options for this. Control points. I've been working on this morning, so I know that should have looked different. I meant to type in 1 there. I have a feeling that it got lost in the shuffle. Let's just make sure that that's correct. Okay. So I've changed the starting. So here's a kind of by mistake, but here is a typical change in parameters. Now I'm not going to create a new alignment for this. So let's just look at the alignment that I've already created. It starts at 4%, so it has to do some cutting. And then it has to move that cut material over to here where it can do some filling. And it's going to cost money to do those hauls. So the cost of this is $534,000, $500,000. 543. Sorry, let me write that down because it's going to go away in a second. And oops, I made a mistake. It should have started at 5%. That was my upper limit. Let's just run it again. I don't need to pre-process because I just did it. And this process doesn't take very long. this optimality gap is telling me that basically the solution was found in the first second or two. And there we go, slightly different underflow, but still small. This is the current alignment, so it updates everything, and right away you can see it's not obvious that there's a big difference here until you see the whole thing. But now you can see that this little bump at the beginning is smaller than it was before, and the cost has gone down to $530. So we lost like $13,000 by allowing that extra grade at the beginning. Could we make it even cheaper? So this is the kind of what if you can play. You can say, well, if I let the beginning be 5%, there it is, 5%, then I can, it's going to cost this much. If I allow that to go up to 6%, it's going to probably cost a little bit less, but then I've got a big grade break at the beginning of my road. Is that, that's an engineering decision. So the optimizer doesn't make engineering decisions unless you tell it very specifically how to make the decision. So for example, I have told it that you can't make a curve that has k greater than 10. So if we look at any one of those curves on here, or less than 10, sorry. If you look at any one of those curves, you'll see that the parabolic k factor is right on 10 because it's using the most flexible alignment that it can to track the balance line. It can't track the balance line perfectly. There's a fill cross-section. Here's a cut cross-section because of the curvature constraints I put in. To illustrate that, what if I just bump up the curvature constraint? So let's now make a new alignment. Let's do a what-if situation. I'm going to change the curvature from 10 to 20. That would be the same as increasing my design speed. Notice that you can do sag and crest independently. There it is. Also notice that you can put in station ranges here. So I could actually have a different design speed for different segments along the road by putting in a station range. Okay, well, let's just do the whole thing for now. So I've changed it. I reprocess. Again, I don't need the pre-process, although it doesn't hurt to do it if you're not sure. I know that I don't need it because I haven't changed the alignment. I haven't changed the cross-section. All I've changed is one curve parameter, so it's going to work fine with the existing cross-sections. I really should label this so that I can see that it's different. So let's do that too after we're finished here. So this one is cheaper. No, more expensive. Sorry, I made the design speed higher, right? So it should be more expensive. 690 versus 530. In fact, we built in a little comparison thing here. So if I click on this, compare with current, and then select that one, the current is 530, and the one that I just optimized is 690. So there's a 23% increase in earthwork costs to go from k equals 10, which would be maybe a 20-kilometer road, to k equals 20, which would maybe be a 30 or 40-kilometer road. So these are resource roads. The speeds are low. That's the kind of what-if situation you can do. There's a whole bunch more. What about creating more reasonable curves? Okay, I just created this thing. Let's see what it looks like. And you can see, first of all, that the curves are smoother, bigger K. And although the mass haul diagram is qualitatively similar, the peaks and valleys are much farther from zero. So there's more haul, more cut, more fill, more expensive. But if I turn on my labels, we've still got a zillion billion curves. Let's try, I'm going to just rename this. This is quick curves k equals 20. Let's create a copy of this one, because I've got some other examples that use k equals 10. So I'm gonna leave that one for now. This one I'm gonna change to k equals 10 so I remember. Just a comment. There's the standard there. Okay, and I'm going to make a copy of this, new, and I'm not going to use quick curves. I'm going to use curves and tangents. So I showed you polyline, curves fast. Now here's curves and tangents. There's two versions of this. They really are very similar. Curves and tangents slow forces you to pick a curve length, let's say 50 meters minimum, and your tangent length is the same. Curves and tangents variable allows you to pick curve length and tangent length independent of each other. So I might do that. And in addition, there's a thing called the base length, which can be independent of those two. Well, not quite independent. They should be multiples of each other. It's kind of artificial in that respect. But what the base length does is it lets you, lets the optimizer start and end curves and tangents at smaller increments. Whereas if I was using the curves and tangents, everything would be on that 50-meter spacing. Well, here now we've got 25-meter spacing to move around on. It's more flexible, so you get a better result. Because it's more flexible, it's more complicated for the optimizer to try all possibilities. That's not exactly what it does. It's much smarter than just simply trial and error, but it can take a long time to deal with all those possibilities. So I'm just going to save this. And I'm going to start the optimization process, because this takes a long time. Okay. Again, I don't need to pre-process, but there we go. So it's searching for an alignment, and it hasn't even found a feasible alignment yet. We'll come back to this in a minute. It's going to take quite a while. So now I'm going to take advantage of the fact that I can run multiple location modules at the same time. I'm just going to open another one. I am going to open that design I just saved. It's read-only because it's actually still open. And then I'm going to save it under a new name. Actually, you know what? I'm not going to bother with that. I have one that I've started, so I'm just going to open that instead. There's the same one. Open user. There it is. Good. Okay. So there's my quick curves. There's my user design. So what I did here is I took basically the same design, and then I went through and I put in all these curves by hand. I just said, oh, you're probably going to want one at the top of this hill and the bottom of that valley, and oh, let's just go straight through here. And I just eyeballed it and threw in some curves. And I didn't even bother to balance. Well, it's pretty close to being balanced, but that's just good luck. And at the beginning here, it's just one long grade. Maybe I'll throw in one curve there too. So let's do that. I'm just going to stick in a curve there. And we'll make it nice and long. Let's go to the curves panel. The default curve would be really, really short because there's no grade change. So I'm just going to put in a reasonable length there. Let's say 20 meters. What does that look like? Ooh, that's not very long either. How about 100 meters? Okay, so what have I done? I've designed an alignment that has some curves in it. And just to kind of illustrate the point here, if I move these curves around, eventually I can get this to balance and be a nice road. But it would take me a while to do that. So here's another option. Instead of getting the optimizer to try and find where to put these curves and tangents so that we get, 15 curves instead of 100 or 10 curves instead of 50. I'm going to ask the optimizer to find for me an alignment based on the curve that I just created, or the profile that I've just created. So I've created a profile. I'm going to now use that profile to design an optimal profile. And I should have renamed that. Yeah. I call it user because I'm using my user curves. So I've got user defined set here. Haven't changed any other parameters. And let's let it go. Now, what's very important about this in this version 7.0 is you do need to have the current alignment on the one that you want as your template alignment, and then this one I can optimize. So I've just reopened this, so it does have to pre-process. While it's doing that, let's look at the other one, see how it's going. Oops. Well, it looks like it finished. Oh no, it's still running. Okay. So we've been running, that took me 240 seconds to talk about what I was doing there. And it's still running. And the optimality gap is 21.95%. What does that mean? That means that we've got a cost here. And we're 22% from the optimal cost, maybe. What we have here is a ceiling for the floor. Anyway, if you take 20% off this value, that would be the best possible optimal cost at this point. However, we don't know the optimal cost, so it's really just the lowest possible. It's actually possible that this cost here is already optimal, and that as it goes through iterations and tries different things, it will eventually discover that this was the best alignment, and it will stop because the optimality gap will reach 0 and it will finish. What's more likely, however, is that this number will gradually decrease. The optimality gap will also decrease, and finally it will finish with optimal solution. You don't have to wait for it. If I'm willing to live with a possibly 20% more expensive design than optimal, I can cancel right now. So I'm going to do that. What is more likely is that you're going to wait till it gets down to 5 or 2 or 3, and then you stop your optimization. And I haven't set this current. Don't forget, let's set that current. There we go. There's variable curves and tangents. The mass hole looks similar. The profile looks similar. How similar? Let's go to quick curves k equals 10 and compare the two. So you can see the current alignment. That's the one I just did. It has tangents between curves. And it's really quite close to the quick curve solution, but not exactly. And you can see the price difference. It's costing, total cost, costing about 28% more. Yes, 28% more. My optimality gap was 20%, so it's possible that if I let it run to optimality, that number would come down to 8%. Not for sure, because we are, with the curves and tangents, we have slightly different constraints. It's going to come up with a slightly different optimal cost. Okay, so the optimizer came up with that one, and as you can see, it's put the curves pretty much where I chose them. Oh, this one's a little different. Yeah, I chose 100-meter curves here, so it's come out a little different from my user design. Let's look back at the user design, and it finished. Didn't take long. In fact, it says here in the list that it took 7 seconds, whereas the optimizer was running for about 200 seconds before. And, oh, that's interesting. Wow. Why did it go all the way down there? Huh. Well, this is not what I was expecting. If I set this current, there never seems to be enough time before the optimization to actually run it all the way through. I get a really bad solution. It is balanced, but the it's got a very gentle. Oh, I know why. I told it to do 5% at the beginning, but I didn't give it a curve there to deal with it. Very interesting. Okay, so let's go back to my initial alignment and move this curve way down to the beginning. And let's actually make sure that we start at the right grade. We're starting at 8%. That's unreasonable. So let's go down to 5%. I got a problem with this curve at the top here. Let's move it back a little bit. What am I doing? I'm trying to set up an initial set of curves that will give me a good solution. Sometimes you can do this, sometimes you can't, and I obviously didn't do it right the first time. Okay, I'm going to leave this. Do I want to leave this or run it one more time? We could run it one more time. What the heck? So let's just shorten this one a little bit to give it some room to move, and run it one more time. Oh, but that gives it a smaller K value. Ooh, that's no good. So maybe I better, yeah, that'll work. Okay, let's just run it one more time. Okay, so this one, process, and I don't think I need to pre-process. Let's see what it does. One more thing I want to show you before we're finished. Oh, I've already gone over time, sorry. And I think I've illustrated one of the points that's important here is that this is not a black box. Okay, that's more like what I was expecting. There we go. So there's a user-defined alignment that's been optimized. So the alignment that I came up with is the red one, and oops, it looks like I missed one of the curves there. That's an intersection point instead of a curve. But you get the idea. The software has said, well, let's move these curves up and down and see if we can get a better solution than the one that you designed. But we'll honor the position of all the curves, and the result is this. Not as good as the one that I just did with the optimizer, because we're up around $850,000, whereas this one is down around 700. So it's better, even though I didn't let it run to optimality. Okay, well, let's not confuse the issue too much. One of the things I wanted to show you, and it is a completely different topic, so if you do have some time pressure and you got to duck out, feel free. It will be on the video. The other thing I wanted to show you is using the vertical alignment optimization to actually help you with horizontal alignment. Oh, something in my throat. Hang on. That's better? Okay. So I'm going to open up an existing optimal alignment. So what I've done here is I've manually moved the alignment around horizontally. So that was the original road. And the original road came out with a, oh, I forget what the cost was now. Let's just reopen that. So the first thing we did with our design, if you remember, is we stuck with the initial alignment that we were given, but we changed the cross-section, and we calculated an optimal alignment, and we've done two of them now. We've done a quick curves, which gave us the cheapest price of $530, and a curves and tangents, which is up a bit. Now, this road horizontally has some very sharp curves. Usually when you're doing a realignment, what you want to do is smooth out the curves a little bit, make the road a bit of a higher design speed. So in the example I just opened, that's exactly what I did. I redesigned the horizontal by hand to give me larger radii, and of course it has to deviate quite a bit from the old road. That's the yellow line there. So I do all that. This is nice LiDAR data, so I can basically go anywhere I want. And now the question is, what's this going to cost me? And the answer is, run the optimizer, boom, there it is, $551. So in fact, to switch from the initial alignment with the same template and so on, let's go back to quick curves. Quick curves gives you, this is a nice fact, pretty well the cheapest possible alignment because it has all kinds of freedom. It can go up and down in any way it likes to. Of course, it has to honor the curvature, but without having to put tangents in between or to put the curves out, make curves a certain length, it's not very constrained, so it can basically wiggle the road into the best vertical position and give you the lowest cost. So that cost of $530 is probably the best we would ever get on this alignment. Now I did exactly the same calculation on this new alignment, and as you can see, I got lots of curves and everything, and came up with a cost of $550, a very modest increase, $530 to $550, to make the road into a much smoother horizontal alignment. And while I was doing that process, I was actually able to recost very quickly and find out whether I was doing the right thing. So if I look at this profile, for example, I can see here that there's quite a bit of cut and fill happening right here. Large cut, large fill. Okay, well, let's zoom in on that spot and see what the heck's going on. Oh, I can see now the reason for that. We're cutting through this hill here, and we're filling up in that valley there. So there's the through cut cross section, and there's the fill cross section. And I look at that and say, well, you know, I can't go too far to the right because then I'm going to be cutting this thing. But maybe there's something I can do up here. Maybe I could move my alignment a little bit to reduce the amount of cut there. So which way is downhill? Well, can I see this all at once? I think so, sure. Yeah, so let's try and move this that way. Oh yeah, you can see the cursor moving in my plan window. I want to go that way a little bit. This is the big hill here. So let's just try that. So what I'm going to do is I'm going to put in a new intersection point here, and I'm going to just drag it over a little bit and anchor it down. Curves don't fit tangents. Okay, that kind of makes sense because I've got all these back-to-back curves underneath. I just changed the alignment length and so on. I still got a vertical alignment here, right? I lost a few curves, but I still got a vertical alignment. and I can instantly see the cost of that. So the cost before was $551, recost. And now it's showing $906. Ooh, that's terrible. Why did the cost go up so much, and what's going on? Well, I haven't done my realignment vertically. You just wouldn't expect the vertical alignment to be in the right place if you just change the horizontal alignment. Okay, back to the drawing board. Start fiddling the vertical alignment and recosting. In fact, there's even a way to do that automatically. This is available to any Rodent user. It's called real-time costing, and basically it means that you can go in here and I'm going to have to delete some curves if I actually want to move these around. Oh, stop that. Okay, let's delete that curve there. Okay. So it takes a little longer to recount because every time I make an alignment change, it recosts, and then this number updates. Well, that's 906. That's better. Let's move this down a little bit, or up a little bit. See what happens up there. Now the cost is 909. Oh, that's worse. I can do this by hand. But why should I? Why don't I just recalculate the vertical alignment? Now, I did change the horizontal, so I better recalculate all my cross sections. So let's recap. I make a horizontal alignment change to really figure out whether that was a good change or a bad change. I need to redesign the vertical alignment. And I need to redesign it carefully so that I can compare the old alignment with the new alignment and get reasonable numbers. Even with an automatic recost, it's difficult to do that reproducibly. However, with the optimizer, I can use the same parameters, the same options, and get a reproducible cost for that horizontal alignment. So there, it's finished. I've recalculated the vertical. It's just a quick curves vertical, but it's a very good quantitative measurement. Cost has gone down to $529. That's actually $20,000 cheaper than it was before. It was $550 before, if you remember. So that little horizontal offset, by putting in that IP there and moving over a little bit, saved me $20,000. Could I have done that by hand by, you know, fiddling it around vertically? Probably. It would take a while. Is it obvious that that change is the right thing to do? Not really. You know, it's not. This is not simple stuff, because when I move that, I'm also moving all these points here and all those points there. So it would be nice to have an optimizer to do this for me, and we're working on it. But at least I've got this relatively quick feedback so that I can use my engineering experience to design an alignment, and then I can double check to make sure it really is cheaper than the old one. That's all I wanted to say for today. Thank you for paying attention. And this is available in the, will be available on our YouTube channel. And I think Aaron wanted to say a couple words to close off.
Yeah, not much for me, but thank you, Dave, for taking us through that look at Softree Optimal. If you have any other questions or want to see Softree Optimal live with your own data, we're happy to do so. You can send us an email at sales@softree.com. If not, we look forward to seeing you at other future webinars. Thanks so much, and have a great day.